감사합니다. 다음 순서로 호주 그리피스 대학에서 오신 시드니 데커 교수님의 기조 연설을 읽겠습니다. 시드니 데커 교수님은 1996년 오하이오 주립대학교에서 인지 시스템 공학으로 박사과정을 취득하셨으며 인적 오류, 시스템 안전에 관한 다수의 베스트셀러를 출간하신 세계적인 안전관리 문제의 전문가이십니다. 그러면 시드니 데커 교수님을 연단으로 모시도록 하겠습니다. 뜨거운 박수로 환영하여 주시기 바랍니다.
Good morning. 감사합니다. Good? Can you hear me? Okay. I will not stand there. And this is my only slide. No more slides. I thought about putting 1 out of 873 in the corner. Then you would go, oh, another 872 slides. No, just one slide. That's it. I am going to explain what I want to tell you today using the stage as a timeline and a organizing principle for my ideas that I want to share with you on this day. The question we need to answer for you today is, what is a smart way of thinking about safety, of regulating safety, given the current state of safety levels and industrialization in Korea? What I want to do is tell you about my experiences with a number of other countries. I currently live in my 7th country. With a number of industries, and to see where they have gone and how that might have worked and how it might not have worked. Okay? That's what I would like to do. At the end of the talk, I hope that you will have seen some pathways that are not very promising, where you go, no, that doesn't sound like a good idea for us. And some pathways that have much more promise for how to manage and regulate safety in your situation. So let's start. Let's start with, as Stefan Rentsch beautifully said, TÜV SÜD, late or the second half of the 19th century, already there's a concern with safety. I'm going to make a little touchdown and a point here about the early 20th century, 1903, 1905, and how people were thinking that they could manage and regulate safety. Then we're going to go to 1911. Very important ideas came out in science and industry at the time, also about how to manage and regulate safety. Then I'm going to make a touchdown in 1943 because a very important insight turned much of what we believed about safety on its head at that time. And then I am going to go to today and what that means for today. Okay, let's start 1903. This is when the industrialized world, including Germany, starts thinking critically about safety for the first time as a matter of policy, as a matter of scientific interest. As said by Stefan, some companies were, of course, already working on this by themselves, but collectively it becomes a concern at the early 20th century. And we already found the solution, supposedly. The solution was that safety problems are created by mentally and morally deficient people. Safety problems are the result of dumb people. The literature actually writes about this. It has definitions for this. Accidents in the main, I'm quoting from 1905. Accidents in the main are the result of carelessness, recklessness, and a lack of attention of the worker. Well, if that's what you believe, how do you manage safety? How do you regulate safety? If that's your belief, then what is the enemy of safety? The enemy of safety is the dumb worker. Now that's 1905. That's a while ago, okay? And this is how we truly believed we had to manage safety. Get rid of the bad dumb worker. Then we will be in safety Valhalla. We will be safe. Now, how did that go for them? Mixed results, quite mixed results. You regulate safety at the individual level. You tell people what to do, you get rid of the dumb people. In 1911, this becomes even more formalized. An important book comes out. Those of you who have MBAs, MBA, by the way, stands for More Bad Advice. So I do not have an MBA. The Australians would say MBA stands for Mostly Bloody Awful. But then they can't speak English. So, 1911, something important happens. The book is called Scientific Management. Frederick Taylor, industrial engineer, together with Frank Gilbert and some other colleagues, he comes with the following proposal. He says, the key to quality and also safety, predictability, productivity, is for the manager and the planner to figure it all out, and for the worker to just comply, to just do as the manager says. Now, there's an interesting assumption in there. Managers are smart, workers are dumb. Right? And if those dumb workers just do as the planners and the managers have prescribed in procedures and in their plans, then we will have a safe system. The enemy of safety in the 1911, again, this is 103 years ago, in the 1911 world, is non-compliance. Is workers who don't do what they're supposed to do. This is what we need to work on. If the enemy of safety is workers who don't do what they are supposed to do, then how do you regulate? How do you manage safety if that is your belief? Well, you go in and you look at the gap between the rules and between how work is done. And you go, a gap. We need to close the gap. We need to remind everybody to follow the rules at all the times. Then we will be safe. Really. Really. Let me give you an example. I was made professor when I was 34, which is a bit young, and so I wondered what to do with my life. So I'm now walking into the time that I turned 34. And so I decided to go fly Boeing airplanes, 737. So I got my ratings and my licenses, and I flew on the 737 as a co-pilot until the airline went bankrupt, and that's nothing to do with me, I don't think. But it was great fun to actually be at the sharp end. The privilege of being a pilot is that you are always the first at the scene of the accident. All right? So that sharpens the mind. But here's an example I want to give you that I think is going on in your workplaces right now as I'm standing here speaking to you. And here's the example about supposedly smart managers and planners and dumb workers who just need to follow the rules. We regularly violated the rule, and a very important rule. Here's what happened. We flew in a rather cold climate like Korea. I was based in Copenhagen, in Denmark. And if there's slush and snow on the ground, then most pilots do not want to set the flaps for takeoff when they are supposed to. You are supposed to do this after pushback from the gate and before moving the airplane under its own power. The reason for this is, otherwise we forget, we dumb pilots. All right? So the procedure, the checklist, double on the checklist, set the flaps for takeoff, flaps 5, check flaps 5, right? It's all on there. Yet we violate the procedure. You know why? Because as pilots, we are told to believe that if we taxi the airplane through slush and snow, we get the gut from the wheels stuck under the wings, and when you take off, that freezes and you can't move the controls. That's bad. So we keep the wing nice and closed, and we don't set the flaps. We violate the procedure. We dumb workers violate the procedure. So we get to the runway, and how do we remember to set the flaps? Now remember, this is an expensive airplane, about $60 million. $60 million if you want to buy a 737. The design has been around for a while. It comes from the 707, so it's been around for 50, 60 years. You would think that all of these smart managers and smart designers have figured it out by now. No. The design is still unfinished. And we, the dumb pilots, have to finish the design. And here's how we do it. On a $60 million jet, we take a 10-cent paper cup and we put it upside down on the flap handle. And we rumble to the runway, right? And like, think about Incheon. You taxi for about half a day, right? Because the runway is located in Egypt somewhere. And so you get to the runway, finally, burning through 2 tons of taxi fuel. And you do your checks, and you go, you look through the cockpit, yeah, that's good. Here's it. What's the, oh, the flaps. Let's set them for takeoff. It's called resilience, right? What that example tells me, people, what that example tells me is that workers are not that dumb. They know the nuances and the risks of their job very well. And in fact, following the rules to the letter may be dangerous. Let me give you another example. Piper Alpha. You know the platform in the North Sea that burned up in the 80s? Almost 200 guys died. Some survived. Who died and who survived when it started burning? Those who died were the ones who followed the rule. The rule was to go to the accommodation block. Those who survived violated the rule by jumping off the platform. Following the rule, designed by smart managers and smart planners, is not necessarily the safe thing to do. Not in a complex world, to use Stefan Rensch's characterization. Okay. So, 1903, dumb people, 1911, people who don't follow the rules, and you already see the problems with those approaches. Let's continue to 1943. The Second World War does a lot with all of the countries that we are part of. But one of the things it does technologically is it creates many new complexities on a very large scale. And these new complexities create new safety and usability problems. People get in trouble using these new technologies. If you look at typical airplane cockpits from the 1940s, one of the incidents that kept happening was that the airplane, after landing, belly flopped. It went through its wheels, and then it sat on the grass. Not good. Certainly not in a propeller-driven airplane. The question was, how do we stop pilots from screwing this up? How do we stop them from making these mistakes by yanking the wrong levers? Well, let's find out. So 1903, what idea did we have? Do you remember? The idea was to get rid of the dumb people. So let's find the dumb pilots. And we get rid of the dumb pilots. Okay. Find the dumb, well, however you do that, I don't know. In my experience, most pilots are dumb, but get rid of the dumb pilots, okay? And it doesn't work. It doesn't help. 1911. What idea did we have in 1911? Let us write another rule and make sure that these dumb pilots comply with the rule. Okay, well, let's do that. So I'm now in 1943, and we're writing a new rule. And the rule says, you shall follow the checklist. Okay. And we will write you another checklist that tells you to use the checklist. Have you used the checklist? And then we'll have another checklist to make sure that you have done the checklist. And then we'll send in an auditor to make sure that you have done the checklist that told you to do the checklist and did the checklist to say that you did the checklist. And so the auditor goes, yes, check. And you know what? We still land the airplane on the belly. It doesn't help. It doesn't help. This is where other ideas were necessary. Alfred Schepanitz, an engineering psychologist, looked at the cockpit and he found two switches, toggle switches. One for the flaps and one for the gear, for the wheels. They looked the same. They felt the same. They were sitting right next to each other in the cockpit. Can you imagine this scenario? You've been on mission, right? You come back, you're tired, you want to land the airplane, you really want a drink, right? And so you've set the flaps, you've dropped the gear, you land the airplane, and you say to your co-pilot, okay, let's park this thing, raise the flaps. Aye, aye, skipper. And there the airplane goes, gah. You sit on your belly. The system is asking you to get it wrong. Hello, I am your cockpit. How would you like to screw up today? Right? The solution was not to tell people to try a little harder. The enemy of safety in this system was not dumb people. The enemy of safety in this system was not non-compliant people. The enemy of safety was a design booby trap that asked people to get it wrong. And the solution was this. People started putting a small wheel on the end of the handle that did the wheel, and a small flap on the end of the handle that did the flap. And today, in all the cockpits that I've ever flown, that's still the case. It's a certification requirement now. And you know what? The accident disappeared. It never happened again. The enemy of safety is not dumb people, not non-compliant people. In this realization, it was a design, a situation that asked people to get it wrong. How often does that happen in your industry? And an important realization was born. It is that human error is not the brain blooper, of a morally, mentally deficient individual. A human error is systematically connected to the tools and the tasks we give people. It is normal work, expected when you look at the design. The question to ask, and this is the very important realization from that time, 1943, the question to ask is not who is responsible for screwing this up, who is responsible for getting this wrong. No. The question to ask is what is responsible? What is responsible? Because if we just get rid of that one pilot, put him in jail, and we leave the conditions in place, it will happen again. Because the conditions that invite the error are still there. That's 1943. What's important there too is that in order to manage and regulate safety well, you need to learn about the near misses. You need to learn about the cases in which it almost goes wrong. Not when it has already gone wrong, because then it's obvious for everyone to see. You need to learn about the cases where it almost goes wrong. And this is where some of the ideas that we still use today were also born. I'm still in 1943. The idea of a safety culture. There is a large literature, most of it is wrong, and the rest is useless, so don't read it. But here's my definition. A safety culture is a culture that allows the boss to hear bad news. Okay? A safety culture is a culture that allows the boss to hear bad news. This is a culture in which pilots, for example, would be able to tell the boss, the squadron leader, whoever is the boss, look, I almost touched the wrong handle here. This is a risky situation. We need to do something about that. But if the boss then comes in and says, you what? You almost crashed my airplane? I'm gonna punish you. Then how much more bad news is that boss going to get? Zero, right? People get very good at hiding evidence of bad news if the boss has made clear that the boss doesn't want to hear bad news. A safety culture is a culture that allows the boss to hear bad news. So how do you manage and regulate safety given those ideas? If that is your realization, if that is your belief. Well, first of all, you manage and regulate safety by making sure that the tools and tasks you give people are not full of error booby traps, like a flap and a gear handle that they can screw up. You make sure that the tasks you give people are not completely goal conflicted by saying, get the job done, but be safe, but get the job done right now, 5 minutes, but be safe, but get the job done, but be safe, but get the job done, but be safe, right? You can either get the job done very quickly or do so safely. You can't do both at the same time in many jobs, right? Managing and regulating safety with these ideas is about managing the conditions under which you make your people work. And it is about you being willing to learn about the things in that work that go almost wrong. You have to be open-minded to that. Recognize that a safety culture is a culture that allows you to hear bad news, okay? I think those ideas still have great relevance in many applications today. So, let's now go to our current era, because if only it were that simple. In a complex world, it isn't. When you look at the accidents that still happen today, I'm particularly talking about fatalities and serious industrial accidents. What we have found is that in many cases, these sorts of incidents that you have no longer predict very well the accident or fatality you're going to have. Let me give you an example. We had a death in Brisbane during a tunneling operation. Big tunnel boring machine, TBM, about 80 meters long. And in order to get that thing to work, the contractor, one of the contractors, had to crawl through it, expose themselves to pretty narrow situations in order to make fine adjustments to the machinery in order to get it to keep digging through the tunnel every day. Now, do you think that that is an incident that they told the boss about? Boss, let me tell you, today I had to crawl all the way 78 meters through the machine in order to get No, it's normal work. They do this to get the job done. This is what happens in your shipyards every day. People do a lot of the little workarounds and run into these obstacles and frustrations and overcome them to get the job done. But you won't hear about it because they don't see it as an incident. It's normal work. This is how we do the job. But then one day, this worker, Sam, crawls in and all but gets decapitated by a piece of the TBM. He dies on the job. Now, we looked at all the incidents that that company had had in the year preceding. And none of the incidents predict Sam's death. It seems to come out of the blue. And this is very true for complex systems. They are not the simple systems from 50, 60 years ago, relatively simple. They are deeply complex systems in which people do a lot of what they see as normal work to get the job done, which is precisely the sort of work that, yes, gets you the results you want, but also exposes them to risk. Think about it this way. You know Murphy's Law? Murphy's Law says that everything that can go wrong will go wrong. Now, that might have been true in 1903. But in 2014, that is no longer true. Murphy's Law is wrong. Everything that can go wrong usually goes right. And then we draw the wrong conclusion. Because we think it will go right again, and again, and again. But in a complex, dynamic world, the fact that it went right yesterday means very little for today or tomorrow. You cannot base your confidence future results on only past results. How do you manage and regulate safety in such an environment? How do you do that in a complex environment? Let me run through at least two ideas and look at some of the advantages and disadvantages. And Karsten has already alluded to one potential model that might work very well in this sort of world, to capture some of these risks that would otherwise go unnoticed. The first solution is to throw more bureaucracy and rules at the system. More rules, more agencies to regulate, more regulations, more audits, more paperwork. There's a couple of rather significant problems with doing that in a complex world. First of all, and when you look at the literature on complexity science and everything, complex systems do not take to top-down approaches very well at all. Top-down approaches are insensitive to the nuances and messy details of how complex systems work. There are three problems I certainly want to mention, if that's the solution that you were thinking about. All right? More regulation, more top-down, more bureaucracy, more agency involvement. The first problem is that these rules do not, this approach does not create more safety. And it really doesn't. When you look at the data from Australia, for example, where I've lived for about 3 years now, and I look back on what they've done for the past 20 years. Over the past 20 years, the amount of regulation and bureaucracy in Australia has almost doubled, particularly with respect to business risk and occupational health and safety, industrial safety. Many, many more rules, more compliance officers, more rule makers, more auditors, more offices involved in the whole compliance business. For 20 years, the efforts have doubled. And what do they have to show? There is no reduction in fatalities in construction, in mining, in oil and gas. Yeah, they may have reduced some minor incidents, rolled ankles or stapled fingers, but that's not the point. They keep killing as many people as they did. So you throw all of this work at it, and it yields no result. You have no ROI, no return on investment. Why is that? Well, let me first give you some numbers. Do not, Korea, do not go the way of Australia. I saw a report last week that told me the following. Managers like Stefan in Australia now spend 8.9 hours each week on compliance-related activities. 8.9 hours of your week goes to paperwork, checking, making sure you comply. Of all your workers, Stefan, 6.4 hours per week go to that. And when you take this to the whole Australian economy, which is 22 million people, probably 3 million people who work. Now, it's probably a little bit more. All the working men and women in Australia, all right, 8 weeks out of everybody's year, 8 weeks go to compliance. Then they start doing work. What do you think that is doing for productivity in my current host country? People are fleeing Australia because it's no longer productive. It's no longer cost effective. They have harmed themselves by overloading themselves with bureaucracy and rules to try to manage and contain this. It doesn't work, and it generates negative side effects. Let me give you the second reason. Remember BP, Macondo, the Deepwater Horizon blowout? 6 years they could show that they had no injuries and incidents. And then one day they blow up and pulverize 11 people. Again, the lack of incidents is no predictor for how you're going to kill people. These are different pathways. But what they commented afterwards was even more important to the point I need to make, which is, and I'm quoting, "We had so many risk processes. They were confusing and difficult to manage." So here's a company that knows it's taking risks, and they have so many risk processes that they become intransparent, difficult, and impossible to manage. And then you blow the thing up. So I'll leave it there. So if you go that route of more top-down bureaucratization, the results from other countries show very clearly safety doesn't necessarily improve, it stagnates. Productivity is harmed, all right? And that goes for workers as well as managers, all right? And so if that's the case, it may not be the route to go. So what else do you do? What can you do instead? Let's move to at least those ideas that Karsten also alluded to. I would want to make a case for a better bottom-up understanding of how safety is made and broken in your workplaces every day. Think about the paper cup on the flat handle. That's not regulated. It's in fact a broken rule. You couldn't even regulate it because the conditions that we have to read and adapt to are so subtle and so nuanced that you can't write that in a procedure. You have to leave that to people's expertise. But think about the tunnel example again. Here we have all these incidents that don't predict how Sam was going to die. He died because he was doing normal work. Not because he was involved in incident after incident after incident, or because he was dumb, or because he didn't follow the rule. He was doing normal work. Everybody in his shoes would have done the same thing. All right? How do you capture something like that? I hope I've already convinced you that that sort of scenario where your people die is beyond the reach of top-down bureaucratic rule-based approaches. You cannot get at it by doing that. You can only get at an understanding of how people create and manage risk locally by coming from the bottom up. And what are the questions to ask? The questions to ask is for you to talk to your workers, but not about safety. Do not mention the S word. Don't talk about safety. Talk about work. Let me give you a few questions that have worked really well for me in many different industries. The first question is, show me how you do it. Oh, well, here's the rule. No, I don't care about the rule. Show me how you do it. Ah, okay, well, let me show you, right? And then let them be the expert. Okay? That's the first question. The second question is, okay, so what's risky about this? What's dodgy? What's dangerous about this? Oh, let me show you. If you stick your hand in here, then that thing might come down, so that's really dangerous. Really? Wow, right? You learn something new. But the third question is perhaps the most important one, and that is this. The third question you want to ask your workers is, what is the absolute stupidest thing that my company is asking you to do every day. You learn really interesting things that way. All right, I've asked this in hospitals, I've asked this in shipyards, I've asked this in construction yards. What is the stupidest thing that your company wants you to do? And you know what? Most often the answer has to do with paperwork, bureaucracy, sign-offs, tick in the flick boxes, audits that have no relationship to real work and how risk is made, managed, and broken every day. What's important about this example of the tunnel is to understand that by throwing more bureaucracy at it, you still won't learn about those risks. You have to go about that, as I said, from the bottom up. And here's the story that I want to finish with to make sure that you get that point and you have a story to work with. Let me go back to the Second World War. And in fact, I have to go back to 1900. A man was born in what was then the Austrian-Hungarian Empire. His name was Abraham Wald. Those of you who've studied industrial engineering, and particularly operations research, will likely have come across his work. He's considered today the father of OR, of operations research. Abraham Wald was born in 1900. He studied engineering, and he was very good at statistics. Very good at statistics. He left Europe, went to the US, and started working for the Allied forces. During the conflict, he was asked to go to England and model the flak and bullet damage on the bombers that came back from their missions over Europe. The idea was this: look, we only have so many airplanes. Resources are being exhausted. But we can put a bit of extra armor on the airplanes. Now, you want to be very careful with that, because extra armor on an airplane is a bad idea, right? It cuts into your range, it cuts into your payload, how much you can take with you, right? So you have to be very judicious and careful of where you put it. So the question to Abraham was, okay, get the data from all the airplanes coming back, look at where the holes are, all right? And then make the model and tell us where we most profitably should put the extra armor on the airplane. All right? So Abraham does this. For 5 months, he gathers data. And he's got lots of big data. At that time, already big data. Right? And after 5 months, his commanders call him in and say, Abraham, we really need to know the answer now. Where should we put the armor? Of course we should put the armor where your statistical analyses show that the holes are most likely to appear, right? No, says Abraham. We need to put the armor where there are no holes, because those are the airplanes that don't make it back to England. We need to put the armor where there are no holes, because those are the airplanes that don't make it back to base. Me being Dutch, this is true. We keep finding them when we start poldering. Oh, here's another, another Lancaster, another B-17. Now, what does that mean? What does that mean for you? I don't think that when you look at the tunnel example I told you about, that in today's Korea, all deaths in industrial safety are predictable by audits, by rules, by bureaucracy. No, many of them are created by normal people doing normal work in what looks to them a perfectly normal and managed situation. And the only way to get at that is to start putting armor where there are no holes. Because in that situation, there are no holes. You just have normal people doing normal work. There are no incidents. But what's the armor? What we've seen, and this is where the literature in safety is going beyond today. It says, let's not worry about safety. Let's start worrying about resilience. Let's start asking questions, not why things go wrong, because most people are not involved in things going wrong. Let's begin to understand, how people make them go right. Have you ever asked that question? Ask your people, how do you make this work? How does this go right? Oh, we use a paper cup. A paper cup? Really? You can learn so much more, right? Those are the paper cup is the armor where there's no holes. It's that type of thing you want to discover. The ability to say no to the boss, to bring the boss bad news. That's the sort of armor you want, even in places where there's no holes yet. This is where you want to move in the future. Let me wrap up. It's coffee break. We've been in 1903. The enemy of safety was dumb people. 1911, the enemy of safety was non-compliant workers, workers who don't follow the rule. 1943, the enemy of safety was booby traps in the design and in your organization of work. The way to manage it is to ask what is responsible, not who is responsible. And then today, the enemy of safety is success. The enemy of safety is success. Remember, Murphy's Law is wrong. The enemy of safety today is the fact that it mostly goes right. And then we draw the wrong conclusion. All right. As you do your discussions today, think about those options. Think about the false pathways. Do not put too much faith in top-down approaches in complex systems, because they are not going to put the armor into place where there's no holes. And that's what you want. Kamsahamnida. Thank you.